Synthetic environments and digital twins are two terms implemented in digital transformation and the 4.0 industry that are generally used interchangeably. Although both terms can be defined as a replica of a living or non-living physical entity, synthetic environments and digital twins are two different things, as I will be explaining. I will be using ReplicANT to showcase its difference, since it provides a coherent interface to implement both synthetic environments and digital twins from the construction of a single model. In replicant.ant-automation.com, you will find the necessary documentation to install and execute ReplicANT and the demo that I will be using in this video. The demo implements a synthetic environment and a digital twin of an experimental photovoltaic plant. To show my point, I'll say that a digital twin is a digital representation of the current state of the operational parameters and data of a physical entity, which in this case is a solar plant. On the other hand, a synthetic environment is a simulation closely mimicking real mechanisms and the physical and environmental conditions of this entity. Digital twins have physical twin counterparts. A digital twin is a representation that reflects the state of a real entity via screens or dashboards. The real-life entity's data is acquired by SCADA systems that were built to operate the plant and that are transmitted on the Internet via the Internet of Things infrastructure that was provided by the cloud. This data is displayed to the user as mimics or dashboards in real time, using tools like Azure's IoT Hub and SignalR. A synthetic environment replaces a physical entity. Physical test runs are slow and costly, and the learned behaviors are very limited. Therefore, we limit the physical environment to game engines. Spread out in an Azure infrastructure that is highly scalable and functioning at a speed of millions of data frames per second, an equivalent of 100 years of experience can be generated in a couple of hours. The synthetic environment reads from a time series database and allows us to apply mathematical functions to this data, like repeating a day of the time series database and varying the wind speed. The system's architecture is composed by ReplicANT Studio, which can either be connected to the real plant or read data from the time series database, and ReplicANT 3D, which implements a model that we want to visualize where the physical motor is run. ReplicANT on-premise is on synthetic environment mode. In other words, it sends the analog or digital outputs and it receives the analog or digital inputs from the programs, moving the mechanisms according to these signals. This generates signals for the sensors that feed the control loop as it happens in real life. ReplicANT on front-end receives signals and reflects them in 3D like a mimic. We want to stress a direct relationship between a synthetic environment and the services of Azure's neuronal networks. With ReplicANT synthetic environment, we can generate a large amount of data from considering scenarios that generally don't occur often in the productive environment. With this data, we can then feed Azure's cognitive service to train its neuronal network so that after being connected to the productive environment, it can help us detect unexpected events and trigger coherent alarms that are based on the current situation and on the acquired experience. First, we open up the simulation in ReplicANT from the directory where we have the demo. Once it's open, we can go to the Trace tab to see the workflows and the time series data that are being loaded up.
Simulation mode activated.
Once the process has finished loading, we can go to a simulation and utilize a set of voice commands to manipulate it. Helios, what's happening?
I suggest activating automatic mode in Sector 10.
Helios, analysis.
Wind speed has dropped below 15 miles per hour. Sector 10 is in flag mode. Energy generation is below 60% with respect to the radiation sensor.
Helios, switch to simulation mode.
Simulation mode activated.
We now are in the synthetic environment, where we can change the environmental parameters. Helios, rewind the simulation by an hour.
Understood.
Here you can see that the sun has changed position. Helios, activate automatic mode in Sector 10. This alert sound is a warning that there's been a problem. We can ask the assistant about it using voice commands. Helios, what's happening?
Failure at executing command switch to automatic in sector 10.
Helios, analysis.
Position can't be reached. Excessive temperature in the motor.
Since we're in the synthetic environment, we can restart the simulation and change the parameters to try and find the problem. Helios, restart the simulation. Helios, decrease the wind speed by 20%.
Understood.
Helios, activate automatic mode in sector 10. This time, by changing the wind parameter, we can see the conclusion of the transition. Helios, what's happening?
Command executed.
We are now switching to digital twin mode. Helios, switch to digital twin mode.
Digital twin mode activated.
Here, we are connected to the real-life entity. You can see how the sun's positions changed once again, since it mimics the current time and is receiving actual data from the physical entity. Helios, activate automatic mode in sector 10. As you can see, the movement of the panel is much slower than before, since it mimics the actual entity. The system will notify us of the completion of the physical movement with a sound. We can use voice commands to confirm this. Helios, what's happening?
Command executed.
With this, we conclude our demo. Thank you.